Welcome to our detailed YouTube tutorial on the second law of motion. In this video, we will explore Sir Isaac Newton's second law, understand the relationship between force, mass, and acceleration, and see how it applies to real-world scenarios. So, let's get started. To begin, let's uncover what momentum is all about. The force, or impact, which a body possesses due to combined effect of mass and velocity is called momentum. Mathematically, it is defined as product of mass and velocity p equals to m multiplied v, where p is momentum, m is mass, and v is the velocity of an object. It is a vector quantity. SI unit is kilogram-meter per second. The force necessary to change the momentum of an object depends upon the time at which momentum is in play. The second law states that the rate of change momentum of a body is directly proportional to the applied unbalanced force in the same direction in which force acts. Force is directly proportional to change in momentum, that is m, v minus u, and inversely proportional to time t. Acceleration, a equals to change in velocity over time, which is v minus u over t. And putting this into the force expression, it becomes F equals to m multiplied a. Let's see how mathematical expression of second law of motion is derived. Consider a body of mass m, at point is such that its initial velocity is u. Force, F is acted upon the body for time, t seconds so it attains final velocity, c. Let it be the acceleration of the body during the change of velocity. Initial momentum of body at a is mu. Final momentum of a body at b is mv. Change in momentum is mv minus mu. According to second law of motion, F is proportional to change in momentum, that is, m bracket c minus u, and inversely proportional to time. On deducing acceleration from change in velocity, force is proportional to the product of mass and acceleration. If we replace proportionality with k, which is constant, and has a value 1, force equals 2 k m multiply a. Putting value of k, which is 1, force equals 2 m multiply a. So mathematically, force is the product of mass and acceleration. Applications of second law of motion. Consider a hammer strikes a nail. It is difficult to tell in how much time the hammer come to rest. In such situations, we measured combined effect of force and time, which is commonly called impulse of the force. Impulse is the product of force acting on the object, and short interval of time, for which it acts on body. So, impulse equals to force multiply time, which is abbreviated as I equals to F multiply t. When we deduce second law of motion, impulse of force is change in momentum of body. Now, F equals to k, converting proportionality into constant, multiply m bracket v minus u bracket close, divided by t. In the next step, t is cross-multiplied with force. We have learnt previously that F multiply t is impulse, which is I, so it is replaced by I. Hence impulse is change in momentum. Impulse of force is a vector quantity, and has SI unit same as of momentum. Examples of second law of motion. A cricket player while taking a catch always moves his hands backward. It is to avoid the injury caused by moving ball. The ball is stopped by player in short period of time. Hence force exerted by the ball is high, so is its impulse. But if the time is increased, the effect of force is minimized. One gets seriously hurt while jumping from the roof to a hard floor, but does not get hurt if jumps on haystack, heap of sand. When person jumps on a hard floor, the time of stopping is very less. As a result, the force applied by the ground on body is large. It will cause serious injuries. While jumping on haystack, heap of sand, the time interval increases, which decreases the effect of force. Hence impact is less and chance of injury is less. Let's recall the mathematical expressions of momentum, second law of motion, and impulse, and learn how to apply in solving numerical problem. A force of 625 N acts on a body of mass 5 kilograms. Find the acceleration of the body. F equals to 625 N. M equals to 25 kilograms. Acceleration, A, is to find out. Formula is F equals to M into A. Rearranging the formula to find out A. Force upon mass equals to acceleration. Putting the values of force and mass given in question, which is 625 and 25 respectively, and then dividing them gives you acceleration, which is 25 meter per second square. Let's do another numerical. A motorist with machine is of mass 180 kilograms. While driving at 90 kilometers (h.r.), he stops his machine over a distance of 10 m. Calculate the retarding force. First we will convert kilometer per hour speed into meter per second. Initial velocity, which is u equals to 90 kilometer per hour, which then converted into meter per second by multiplying with 5 by 18, which is 25 meter per second. Final velocity, which is v, equals to 0. Mass, which is m, equals to 180 kilograms. Distance, which is s, equals to 10 meter. A is to find out. First we will find out acceleration using formula. V square minus u square equals to 2as. Putting values of u, c, and s, the acceleration is minus 31.25 meter per second square. Now, formula of force is F equals to m multiply a. Putting values of mass and acceleration, the expression becomes F equals to 180 multiply 31.25, which is 5,625 Newton. Now, it's time for you to practice some. Pause this video and solve these numerical. If you have any questions or want more practice, feel free to leave a comment below. Don't forget to like this video and subscribe to our channel for more exciting tutorials on science and beyond. Thank you for watching, and keep exploring the wonders of physics and motion.